Today we are going to look at solving linear equations. So we will be covering how to solve one-step equations, two-step equations, and general linear equations where variables are present on both sides of the equation. Solving formulas for a given variable, that is isolating a given variable in a formula, and linear equations with fractions. So let's look at one-step equations at first. So here I have four one-step equations where you can get the answer in a single step. So in the first one we have v plus 8 equals 16. So in order to find the value for v, I can simply like so. I add minus 8 to both sides of the equation. So plus 8 minus 8, 16 minus 8. So if you compare the first expression and the second one, you can see that there is essentially no difference, because the same thing has done to both sides of the equation. Minus 8 to minus 8 should be cancelled out. But if we do the sum, we can see that in this side it will be cancelled out for this plus 8, and in 16 minus 8 the remainder is 8. So v equals 8. Minus 1 plus k equals 3. So in here I have to isolate or find the value for k. So in order to cancel out the minus 1 in the k side, I can simply add positive 1. So that way I can cancel out this minus 1 and plus 1, making sure that k is isolated and has a value of 4. X minus 4 equals minus 20. So in order to remove the minus 4, I can simply add plus 4 to both sides of the equation. So x minus 4 plus 4 equals minus 20 plus 4. These two will get cancelled out. X equals 16. In the third equation I have minus 20x equals minus 70. So I simply divide both sides by minus 20 to make sure x is isolated. So if I do that, this will get cancelled out while isolating x, and in here I can cancel out this 0 to this 0 and minus to minus. So x equals 7 over 2. K over 13 equals minus 2. Now I have to remove 13 from this side, so I simply multiply both sides with 13. So next I have two-step equations where the answer is taken in two steps. Now the first equation, 4x minus 20 equals 12. So first of all I had to remove the minus 20 from both sides, and then I had to divide the whole expression by 4, which will ensure that x is isolated. So 4x minus 20 plus 20 equals 12 plus 20. This 20 to 20 will be cancelled out, leaving 4x into 32. And in order to remove 4, I divide both sides with 4, leaving x equals 8. The second equation, 27 equals 21 minus 3b. First of all I remove the 21 and then the minus 3. So 27 minus 21 equals 21 minus 21 minus 3b. In this side we have 6 and equals minus 3b. So to remove the minus 3b, I divide both sides by minus 3. So leaving b equals minus 2. In the third equation, we have minus 5x plus 2 equals 27. First of all, I will remove 2 from both sides and then the minus 5. So minus 5x plus 2 minus 2 equals 27 minus 2. These two will get cancelled out. Minus 5x equals 25. Dividing both sides with minus 5, leaving x equals minus 5. The fourth equation, minus 11 equals minus 8 plus k over 2. Now this one is a bit tricky because we have k over 2 as a fraction right here. So first of all, I'd say that either you can go in two ways. You can either remove minus 8 and then remove 2, or remove 2 and then remove minus 8. So since we always used to remove the constant first, this time I will remove the fraction value, which is k over 2. So I'll just get rid of 2 and then get rid of minus 8. So to get rid of 2, I simply have to multiply all the variables and constants here by 2. So minus 11 into 2 equals minus 8 into 2 plus k over 2 into 2, which will get rid of this k over here, and then leaving minus 22 equals minus 16 plus k. So it's just a matter of getting rid of the minus 16. So I'll say minus 22 plus 16 minus 16 plus 16 plus k. So in this case, k equals minus 6. So the last two-step equation, the fifth one, we have minus 3x plus 3 equals 3. So I'll use the same previous method where I'll remove the this constant right here. So I'll divide the entire equation by 3. So 1 1 plus minus x. So to get rid of 1, I'll simply remove, I'll add minus 1 to both sides. So minus x plus 1 minus 1 equals 1 minus 1. So minus 1 minus x equals 0. And if I multiply both sides with minus 1, I can make sure that x is plus, x equals 0. Next we have general linear equations where the variables are on both sides of the equation. So to begin with, first I have to extend this expression to make sure it is easy in order to remove and transfer constants and variables across. So 4 into 2, 8b minus 24 equals 16. So after this, it's simply the same method as the previous one. So 8b equals 16 plus 24, since I added plus 24 to both sides, which will give me 40. So dividing both sides with 8, I can get b equals 5. In the second equation, I have 3 into 2a is 6a minus 3 into 4 is minus 12 plus 9 equals 15. Now I can remove minus, in order to remove minus 12 and plus 9, I add plus 9, minus 9 and plus 12 both sides of the equation, which would give me 6a equals 15 minus 9 plus 12. So 15 plus 12 is 27 minus 9 is 18. So 6a equals 18, A is 3 by dividing both sides with 6.